I want to give you an additional example about how to find domain and range using equations, because we didn't have an example like this in the top part of this page. So under how to find domain and range using equations, domain is going to be the set of all allowable values of x in the function, and many times that will be all real numbers, but remember we said there's some restrictions to that. Any x value which creates a 0 in the denominator, any x value which creates a square root or other even root of a negative number, and then we have some other special cases which we'll go into more later. But I didn't have an example for this first one right here. So let's look at an example of an x value which creates a 0 in the denominator. So let's just say we have f of x equals 1 over x plus 2. I am not allowed to divide by 0 because dividing by 0 results in an undefined number. So that means x cannot equal -2 because that would make the denominator equal to 0. So let's think then what x can be. X can be anything except -2. So if I have a little number line here of possible x values, here's where -2 is. And I can't use -2, so I'm going to say can't use that one, but I could do anything to the left of -2 or anything to the right of -2. To the left of -2, I'm always going to go all the way to -infinity, and to the right to positive infinity. So the way I would write this domain symbolically is I would write the two sections, -infinity to -2. That doesn't look very good the way I wrote that negative sign. Try that again. To -2. And the other section would be -2 to positive infinity. And in between, I'm going to put this little symbol which means union, or. It's just sort of a right side up U. It means or. Okay, so that's or. So I'm saying -infinity to -2 or -2 to positive infinity. So basically we're saying -infinity to positive infinity, but there's this little gap right here where -2 is not included in either of these sections. It's just left out. Okay, so that's the domain. Now we're going to look at the range of the same function. Now I would rather change this to set of all allowable values of y. Let's put the set of all possible values for y. Okay, so given that we have this set of allowable values of x, what possible values can I get for y? So using this same function, 1 over x plus 2, I know that I have two sections in my range, or my domain. So in my domain here, I have -infinity to -2. So if I put any of those values into the function, so like -3, -4, -5, anything, I'm going to end up with 1 over a negative number, because the negative number, the x is going to be a number that is more negative than 2 is positive. So like -3 plus 2 is -1, for example. So I'm going to end up with a negative number. So for this section of the domain, y is going to be less than 0. Now for this section of the domain, -infinity to positive, or -2 to positive infinity, so let's say something bigger than -2, like -1 or 0 or 1, any of those numbers are going to result in 1 divided by a positive number, so y will end up being a positive number. Now in this case, y cannot equal 0, and this falls into this category right here. In a rational function, this last statement here, in a rational function, the only way y is equal to 0 is if the numerator equals 0. A rational function is an algebraic expression in fraction form where there are variables in the denominator. If the numerator is 1 and the denominator can't equal 0, there's no way to make the fraction equal 0. The fraction can only equal 0 if the numerator is 0. Not the denominator can't be 0 because that's not even a number. So there's no way for y to equal 0. So the range here then is that y is less than 0 or y is greater than 0, but y can't equal 0. So we have the same sort of situation we had with the domain in the previous one, is we're going to say -infinity to 0 or 0 to positive infinity. So I wanted to give you one example of that since we didn't do one in the previous examples where we had some other issues going on with domain and range.